us now discuss this question in equations. S be the set of all real roots of the equation 3 raised to x into 3 raised to x minus 1 plus 2 equal to modulus of 3 raised to x minus 1 plus modulus of 3 raised to x minus 2. Then S is the set of all real roots of this equation. What is meant by roots? Roots are the values of the variable satisfying the equation. Here the variable is x. So you should find the number of values of x satisfying this equation. Before we solve this question, I advise you to go through the topics which I discussed in continuity and differentiability for the functions modulus of x minus 1, modulus of x minus 2, etc. So please go through that topics, then come back to this question. Anyway, in this question, one important thing which you have to observe is this: there is a particular term or factor or a function present in the equation. What is that particular part? 3 raised to x. So let us put first 3 raised to x is equal to t. That is what the first thing we do to solve this question. So we substitute. So put 3 raised to x is equal to t. Therefore, the equation becomes, it is t into t minus 1 plus 2 equal to modulus of t minus 1 plus modulus of t minus 2. Since the right-hand side is a combination of absolute value functions, there are certain cases to be discussed. Modulus of t minus 1 will be positive whenever t is greater than or equal to 1. It is negative whenever t is less than 1. Similarly, modulus of t minus 2 is positive when t is greater than or equal to 2, negative when t is less than or equal to 2. So there are 3 cases arising. The cases are, what are the 3 different cases? The 3 different cases are: 1, t is less than 1, 1 less than or equal to t less than or equal to 2, and t is greater than 2. These are the 3 cases. So we will discuss one by one the cases. Okay. First of all, case number 1. We go to case number 1. What is it? It is t is less than 1. When t is less than 1, what will happen? T square minus t plus 2 equal to, t is less than 1, both these terms are negative. So for the right side, it will become 1 minus t plus 2 minus t. So this minus t cancel, 2 and 2 cancel. Transfer the right side to the left side. You get, this is t square plus t minus 1 equal to 0. Remember, the value of t should be less than 1. This is a quadratic equation. We solve, t will be equal to minus 1 plus or minus root of p square 1 plus 4 divided by 2. That is equal to minus 1 plus or minus root 5 divided by 2. And you know, minus 1 minus root 5 by 2 is negative, which is smaller than t, smaller than 1. So t is equal to minus 1 minus root 5 by 2. This is an admissible value. Now, what about the other value? T is equal to root 5 minus 1 divided by 2. Root 5 is 2 point something. Minus 1 is 1 point something. 1 point something divided by 2. That is also smaller than 1. Isn't it? So this is negative. Now, this is also an admissible value when it comes to t less than 1. Now, what is t? I told you in the beginning, solution is the value of the variable satisfying the equation. Now, t is a substituted variable. Now, what will be t? T is equal to 3 raised to x. What is the property of this exponential function? 3 raised to x should always be greater than 0. That means t should always be greater than 0. Hence, the first value is inadmissible. Therefore, t has got one and only one value in this case, that is root 5 minus 1 by 2. So the solution for t, both are admissible, but t is a substituted variable, and 3 raised to x, that is an exponential function which is always greater than 0. Hence, the value of t should always be greater than 0. So t is equal to root 5 minus 1 by 2. Therefore, definitely once element is there in the set, yes. Therefore, empty set is ruled out. This is ruled out. We will go to the next case there then. What is the next case? That is this case, 1 less than or equal to t less than or equal to 2. We will say that 1 less than or equal to 1 less than or equal to t less than or equal to 2. So in this case, the equation becomes, what is the equation? Equation is already there. This is equation number 1, and this one becomes t square minus t square minus t plus 2 equal to, if t is bigger than 1, the first term is positive, second term is negative. So the right side becomes t minus 1. That's positive. Then plus the second term will become 2 minus t, because t minus 2 is negative. So 2 minus t will be positive. So from here, t and t cancel. This 2 and 2 cancel from both the sides. So this is equal to t square minus t plus 1 equal to 0. You know this is a quadratic equation. Here the discriminant is less than 0. Therefore, t is not real. Therefore, t belongs to null set. Hence, no solution here. No solution. In the second case, there is no solution. Case 3. What is that case? T is greater than 2. When t is greater than 2, the equation becomes, what is that equation? It becomes t square minus t plus 2 equal to, both the terms on the right-hand side are positive. Therefore, it is t minus 1 plus t minus 2. So this is t square minus 3t. Here is a minus t and 2t from right side. It becomes minus 3t. Then minus 3t. And this will become plus what? 5 equal to 0. What is discriminant? 9 minus 20. Here also discriminant is less than 0. Therefore, t is not real. Hence, there is no solution. So, no solution. In the third case also. So, finally, t has got one and only one solution, that is root 5 minus 1 by 2. Therefore, S is a singleton set. Okay. We have discussed the modulus of x minus 1 plus modulus of x minus 2 in the topic continuity and differentiability. Please go through it. Okay.